Hello students, don't fear, I am with you. Let us learn together. So today we'll learn to find inverse of a matrix by elementary row transformation. I know students, you are not comfortable with this because it is not that much interesting, but for the sake of examination, you must learn it. So let us learn. Inverse of matrix of elementary row transformation means you have to change the rows and we'll do some operations to get the inverse of a matrix. And we'll start today by 2 by 2. In the next video, we'll go for 3 by 3. So let us take an example. Here concepts we use A is equal to I into A. That means any matrix, of course it is a square matrix, then only you can find the inverse, is identity matrix multiplies by the matrix itself. In the same way, this identity matrix is equal to product of inverse matrix and the matrix. So what we'll do, we'll write A and we'll change to the next step I so that automatically the identity matrix will change into the inverse matrix. So the concept is we'll change A into identity matrix and by some row operations, and same operation will be carried on right side on identity matrix, keeping A unchanged. When A changes to identity matrix, automatically identity matrix changes to A inverse, as we are keeping A constant, we are not changing. So when we'll go, for example, you will understand better. So let us take example 2, 1, 4, 3. So first is we'll write the concept. What is it? Now the matrix A is equal to identity matrix into A, and now we'll write this operation in matrix form. So it will be 2, 1, 4, 3 is equal to 1, 0, 0, 1 multiplies A. So as we have discussed, this A on the left side will change into identity matrix, and whatever change will be carried on the left side, same operation will be done on the identity matrix, and at last we'll get identity matrix in the left side and right side will get A inverse. We won't get, we have to get it, we have to do some operations and it needs thinking also. So let us start. So first position we have to change is this 2. 2 we have to change into 1 because A11 position in identity matrix is 1. So how to do it? You can say it, you can multiply with half. But I don't want to do that operation because since the beginning I don't any fraction in the matrix, so that it will be difficult to write. So what I'll do to change 2 to 1, I'll write R1 is equal to 3 times of R2, my R1 minus R2. Just see this operation. R1 row 1 elements is equal to 3 times of row 1 elements subtracts R2 elements. That means 2 multiplies 3 is 6 minus 5, that will be 1. So in this operation I can change 2 into 1, and when I change 2 into 1, automatically other element on the same row 1, it will also be changed, and same operation will be carried on the identity matrix also. So while doing, you should be very careful that each step should be followed. So what will the result? Result will be 1. Now second element will be 3 times of 1 minus 3, it will be 0. And coming to identity matrix, 3 into 1, 3 minus 0 is 3, and 0 times 3, 0 minus 1 is minus 1. As it is a slightly thinking process involved, so I am going very slowly so that you can understand better. But while doing, you can do first. Next position I'll change, that will be A21. This position. This position I'll change into 0 because in identity matrix A21 is 0. So how to change into 0? This is the procedure. R2 is equal to R2 minus 5 R1. So it will be 5 times of row 1 subtracted from R2. So this is the result. It will be 1, 0, 0, 3, and here 3 minus 1 minus 15, 6. So 0 is changed. The second position is changed. Next we'll go for A22. That means we'll go anti-clockwise. So I'll change 3 into 1. How to change? Here I can multiply 1 by 3. So it will be 1 by 3 R2. Of course, you will write the operation with row. That arrow symbol, it is not equal to previously these two steps. I have committed some typing error. So R2, you will put an arrow that is equal to 1 by 3 R2. That means 1 by 3 is multiplied to R2, and R2, that same will be written in R2. So what will the result? Result will be 1, 0, 1, 0. And the right side, see the operation? It will be minus 15 into 1 by 3 minus 5, 6 into 1 by 3, that will be 2. So here I am getting identity matrix in the left side. And what you have to keep in the mind, you have to keep in the mind that whatever operation you are writing, same you have to do for the whole element of that row or that R1 or R2. So after getting identity matrix on the left side, our job is finished. We'll recall now the expression I is equal to A inverse into A. So whatever with A, the new matrix changed from the identity matrix is equal to A inverse. So A inverse is equal to 3 minus 1 minus 5, 2. So this is only the elementary row transformation. Now let us take another example so that you will understand better. So A is equal to, and here I'll go slightly fast. 2 minus 3 minus 1, 2. So we know that this is the expression I is equal to 1, 0, 0, 1. Then you write 2 minus 3 minus 1, 2 is equal to 1, 0, 0, 1 into A. Next I'll change 2. This 2 will be converted to 1. It is very simple. I'll applying R1 is equal to R1 plus R2. I'll get 1. Similarly, minus 2 plus 2 will be minus 1. And on the right side, 1 plus 0 is 1. And 0 plus 1 is 1. Next is minus 1 will be converted to 0. So it is again simple. It is seen that R1, R2 can be added. Now applying R2 is equal to R2 plus R1. So I'll get simple 0 at 2, 1 position. So 1 minus 1, 0. And here 2 plus minus 1 is equal to 1. So I am getting the third also as 1. So work is less now. Next is to convert minus 1 as 0. I'll do R1 plus R2. R1 is equal to R1 plus R2. So it will be 1, 0, 0, 1. And here the change right side will be 1 plus 1, 2. 1 plus 2 is equal to 3. So what is the inverse? So we got in this form, identity matrix is equal to A inverse into A. So what is A inverse? A inverse is equal to 2, 3, 1, 2. You can practice some more questions so that it can be fast. Next, I'm finding a short method to find whether you have done correct or not. So verification of a result by quick method. A is equal to suppose A, B, C, D. Then determinant is equal to AD minus BC. If determinant is 0, then A inverse does not exist. That time we call it singular matrix. If it is not 0, not equal to 0, then only you will go for the inverse. Now what is the inverse? It will be A inverse is equal to 1 by determinant A into D minus C minus B A. That means just change diagonally, and you know that when we write the cofactors, these right diagonals will be changed. So it will be minus C minus B. And just see whether you are getting the same or not. Then it is verified. Thank you for watching. So please share the channel so that you can see more videos. Thank you.